Alrighty, so in our tour of the planets, we are now at Jupiter. And as I start this video on Jupiter here, just go with a bit of that caution here, because this planet is just unbelievable. It's like nothing you've ever seen, and it is really something. Let me just give you a little bit of an intro here, and we'll get into more specifics in the following videos here. So the first of all, on my solar system map that I like to sort of put up when I talk about the planets here is, of course, here's the sun right here in all of its glory. And Jupiter is the first planet we get to that's on the other side of that so-called frost line. So it's over here where the gas giants formed, as you can see, and over here where the rocky planets formed. And we discussed in the formation of the solar system why that was. Now, the funny thing about Jupiter is when you get sort of on this side of the frost line here, there's a lot of familiar components to these planets here. In particular, they're rocky. We discuss issues of clouds and being cloudy and that sort of thing. We discuss issues of an atmosphere, and maybe we discuss things like, liquids, or even maybe if there's some water there. We discuss just a lot of familiar things and compared and contrast. And okay, Mercury's all cratered and very barren and things. Venus is very hot with that thick carbon dioxide atmosphere. Earth is, everything you know about it. And Mars is a little bit smaller than Earth, about half the size. Very thin carbon dioxide atmosphere. But at least when we brought up these terminology about what the planets were like, there was some things you can imagine they were familiar. You just got to throw it all out when you talk about Jupiter, though, because Jupiter is such a different planet. And in particular here, the idea here that all these planets are gas are actually true. So Jupiter here is primarily made out of so-called molecular helium and hydrogen, and really to the tune of almost 100%. So that's just really all Jupiter is made out of here. And if you remember the helium and the hydrogen here, these were the really simple atoms, okay, on the very top of the periodic chart. And it's that stuff that our original, the primordial dust that the solar system even formed from was. Remember that the dust of the initial nebula that we formed from was also sort of a similar composition like this here, the helium and the hydrogen. So Jupiter just sort of formed from that. And that's sort of the, the story of its composition here. So there's nothing to stand on. There would be no standing if you ever went to Jupiter. So you just sort of couldn't do this because it's all gas. There isn't anything solid, no rocky surface or anything like that. And so here's another chart that sort of shows you the size comparison. You can see down here, here's the Earth and Venus and Mars and Mercury. Those are those inner rocky planets that we discussed, and they have these familiar attributes. But then sort of when you go over here and go, well, gee, there's Jupiter there, or excuse me, yeah, there's Jupiter there. And it's like, wow, it's just huge. Just absolutely enormous. So let's take a good look at it here as I give you a few more sort of issues on its hugeness, because that's sort of maybe the first thing to do, to just know about Jupiter is how big it is here. So you could fit 1,300 Earths inside of it. So if you wanted to come here and start drawing little balls that you wanted to represent as the Earth like this, you'd have to do this 1,300 times to fill up Jupiter here. Jupiter's mass is more than 2 times the mass of all of our planets combined. And let's just say if it was just, and I'll put the word just here in quotes, 80 times more massive. If it was just 80 times more massive. Now, I realize that's a big number because it's almost something like 80 is close to 100. That's a big thing to expect in science. Something is 100 times more massive, or even 10 times. But all right, 80 times it is here. Could be a star. So in other words, if Jupiter just had 80 times more mass, it might have ignited and become another sun, believe it or not. It's just that type of planet here. And on the hugeness here, you know that the gravity on Earth is something like 9.8 meters per second squared. Well, on Jupiter, it's something like 25 meters per second squared, because if you were sort of standing or doing something like that on Jupiter, well, you couldn't stand on Jupiter, but if you were somehow around Jupiter like this, that inner pull of gravity here would be 25 meters per second squared, which is something like 2.5 times the pull of Earth. So you would just be incredibly heavy there. It'd probably break your back and all that sort of thing. And just a few closing comments here in this video, so I hope you get this size in mind here. Another couple things about Jupiter here is in terms of energy, it's actually emanating energy. to the tune of like 1.67, a factor of 1.67 or so. So what this means is like if this number was less than 1, Jupiter would be taking in energy. If it was 1, it would sort of be equal in energy, balancing energy with the solar system. But it's actually emanating energy, and I think it might be sort of the original formation energy. So when Jupiter started to form and all the hydrogen and helium started to come together, energy was released. And so the energy that's still coming out of Jupiter is still from the time when it formed 4.5 billion years ago. And then the last thing I'll say in this video before moving on to something else, if you took sort of a cut of Jupiter like this, suppose you went in there and you took sort of a cross-sectional cut like this, and you looked at what you would get, you would definitely get sort of like there's going to be a bunch of gas up here. As we said, Jupiter's all gas floating around. But as you get deeper and deeper into the planet like this, as you get deeper like this here, then as you might expect here, the pressure of all this gas that would be on top of you just starts to go up. So the pressure definitely starts to rise in here. And what will happen as you start getting more and more pressure on the gases is it actually becomes liquid in here. Now it's still hydrogen, helium, but in this sort of these inner parts here where the pressure gets really high, there's liquid hydrogen in here, which sort of behaves like a metal. And of course, Jupiter does rotate, so the liquid metal will be swirling around, as you might expect. So Jupiter does have a very strong and large magnetic field. And the magnetic field would be something like 14 times that of Earth. So good solar wind protection, not that you need it, nothing would live there. But there's just a few preliminary facts on Jupiter, so we'll pick up with a few more in the next video.